Hello everyone, and welcome back to a new episode of SHENZHEN I. Let's just dive right into the next puzzle. We finished up the haunted doll last time, and it looks like next up we have an aquaponics maintenance robot. What the heck is that? Surely many of you have heard of Sun Hakchun? How-Chun. Not sure what to do with that T sound. How John? I don't know. His father was one of the first electronics entrepreneurs from the area. Okay. It was special economic zone. Now he's inherited the business. It would be no exaggeration. He's the most powerful man in Shenzhen. An opportunity has arisen to work with this conglomerate on a device that moves between stations in a line. Apparently it's intended to service an automated aquaponics facility. It's a small start, but understand that our relationship with him is absolute top priority. If he feels he can trust us, we'll continue to get bigger and better. What is an aquaponics? A system for growing food that combines aquaculture and hydroponics. Okay. The robot probably cleans or adds nutrients in the system as needed. Well, this all sounds a little bit suspicious, I suppose. Alright, so we have 3 outputs and this one wireless input, it looks like. Okay, yeah, so non-blocking X-bus input. Motor is an output connected to a bidirectional motor. So I guess probably 50 is neutral or something. This is new music. Huh. That's kind of cool. Tool clean and tool feed are outputs connected to unknown tools. The robot begins in station 0, pulsing it to 100 and then back to 50 will move it to the next station. 0 and back to 50 moves it to the previous. When a data packet is received, move to the destination station and activate the tools for the duration. I see. So we're gonna get a 3-part packet that tells us what to go to, and then okay, and also like how long to activate each of these. Right. So yeah. Starts at, I presume, at station 0, it said? I don't remember what. Yeah, station 0. Okay, so what are we going to have to know? We're going to have to know what station we're at. Like, that's going to have to be something we remember. There's no way we can do without that, because we'll get told to move to a particular station. We're just going to have to do that. Okay. And here's an interesting thing. It takes a non-zero amount of time to move to a new station, right? So like, if we get told to move to station 2, that takes like 4 time units just to move there. And then once we arrive, we're gonna have to then like do this, activate the tools for a particular duration of time, right? But we won't be able to just at that time read how long the tools were supposed to be active, because that input will have long since gone away. So we're gonna have to save it somewhere. I suppose, like, well, there's a few. I guess we kind of have to save it in a register, sort of. Maybe we can somehow save it in an X-bus line, I'm not sure. But those are both sort of similar, I think, because in order to have an X-bus line that's pending, we would need another chip that's waiting, and what would it be reading it into? Probably into a register. So, okay. those are kind of the three things we need to store. We're going to need one main controller that reads the inputs and knows how knows what station we're at. So, okay, one thing we could consider, excuse me, is having, like, let's say in sort of the worst case, having one of these guys per output, right? Have one guy who controls this thing, the motor, and one guy who controls this, and one guy who controls this. It seems likely that we can do a bit better by having one guy control both of these, since the function there is pretty simple. I'm thinking about how it's going to coordinate its communication with the master controller. It's a little bit awkward to figure out how to send, because the master controller kind of wants to send this guy the signals about how long to activate the tools before the controller actually starts activating this motor, right? But then it also wants to it's a little, like, we kind of have to send them in the order that we got them. This, I don't know. I'm not sure I can articulate too well what I'm thinking about here, sadly. But it seems to me like it might be more convenient if we got these packets, these two packets here, in the opposite order. Because, well, actually, what order do we get them in? Radio RX, yeah, okay, so... Okay, I guess it's telling us it's the order, so we're doing clean and then whatever, but... imagine if we could, like, get them in the opposite order. We could sort of send the thing to do last over the wire, and then it would save that into its buffer. And then we would send the thing to do first, and it would just do it immediately. That doesn't actually help, because we still can't do it immediately. We have to have the main controller move the motor before either of these activates, so I don't think it matters that much. Okay, do we have any special new tools that we haven't seen before? No, we haven't unlocked anything new. Well, we have this. We don't really know what that's all about. I guess we could go read what it's about. It's not recommended, but I guess it would be interesting. So what is 100p-14 here? It's another random access memory. So it seems the same, right? Oh, it's a read-write memory cell, is that right? Yes. Okay. Well, we don't really... Well... That actually could be pretty handy, couldn't it? That's a way to store more bits of information. Okay, so that's a thing we could consider. It's a little bit, like, it's cheaper than, like, let's say in the worst case I decided I needed to store everything in a register. It'd be like, okay, well, let's have two of these guys and each one store their command for this in a register. It would be cheaper, to just have some RAM here, since it's 2 yen instead of 3. Alright, that's an op. We definitely don't need that. This is like ands and ors and stuff still. Yeah, okay. So those are, we have logic gates, which we are not interested in at this time. Interesting. Uh-huh. So what is the main controller's code gonna have to look like? It's basically like gonna have it's gonna have to read in a... So it's gonna store in some register, probably accumulator. I was going to say it's gonna store what station it's at, but it also needs to store, like, what station it's going to? Because it needs to, at a given time, at a given point in time, it needs to know how far away it is from where it should be moving. And until it reaches where it's moving, and then it needs to know where it is. And I don't think you can keep both of those in one register. I think we need to use, you know, both DAT and accumulator for that. Okay. So all the storage in the main chip is dedicated to keeping track of the motor's location. Which means that stuff about how long to activate the tools for needs to live on a different chip. We use, like, okay, so if we decide to use the random access memory, we're gonna have to write, like, well, we'll have to send at least 3 messages from here, right? 2 messages to the RAM controller telling it where to, telling it what values to store, and 1 message to this other chip to wake it up. Now, alternatively, we could just send 2 messages to like different chips, MC whatevers. And actually, you know, instead of using one of these and a RAM chip for $5, why not just use one of these for $5, which happens to have 2 registers, which is all we need, right? That's way simpler, isn't it? So, yeah, that seems like the thing to use over here. I'm pretty confident in that, so let's just go ahead and wire it up. Okay. And let's put this guy down as well. We have a lot of space for wiring stuff up on this one. I don't know why we're going to need that much space. Anyway, and it only needs 1 X-bus connection as far as I can see. And we will also wire that up. Right? Sure. So here's this guy's thing. He's just going to sleep until there's input available. He's going to move X1 into ACK, move X1 into DAT, storing both of the things we need to do. And so he needs to do all of this, and then like go back to sleep, basically, right? So we'll sleep X for X1 again. Oh, that's interesting. We have to somehow, we have to wake him up. And so, I guess the thing that we can do, seems a little silly, is just, we'll receive a message from this guy telling us to wake up, I guess. And, yeah, okay, so what we can do next is use that message as the 100. So rather than writing 100 to this thing, we'll just write whatever we get from XBus to it. So we'll gen... oh, wait, does that actually work? It doesn't. It doesn't. Whatever. We'll move X2 into P1. X1 into P1. Sleep for the amount of time in ACK. And then gen on P0 for dat and 0. Yeah, that seems okay. I think that's all this guy ever really needs to do. And let's see what this guy needs to be up to. So we're going to, I don't know, conceivably, in fact, we might even need another controller chip. Like maybe understanding this wireless thing is more expensive than, it takes up too much space to also let us control the motor on the same chip, but I don't think that's true. Now, hang on. Why am I using a large chip here? Why did I decide to use a large chip? Ah, for the 2 registers. Yes, okay. I was thinking we could shrink it, but we can't. And likewise this one, even if we figure out how to do it in less space, we're going to be using both registers to manage the motor's position. Or manage the position of the thing and control the motor for it, I guess. Anyway, so what do we do here? Ah, go away. I guess the first thing to do is decide in which register we're storing what. So we kind of need ACK and DAT to hold like 2 things. One is the station we're at, and another is the station we want to be at, right? And we're gonna have to add, I guess, to the station we're at. So let's store that in ACK and store the other one in DAT. That seems all right. I asked that because the first thing we read, we have to store it somewhere so that we can test whether it's equal to 999. Minus 999, I should say. And so I was like, well, which register do I move it to? And I think we want to move it into DAT. So move X0 into DAT. Test equal DAT of minus 999. Now, do we need any conditionals? If so, we'll need to jump to the end here. I guess we're going to need conditionals later to do the motor stuff. So let's say if it was equal to jump done. We'll write done later, I guess. Well, let's write it now so the thing gets mad at us if we don't. But done is just sleep 1. There we go. Now that we've read dat, we need to send the tool activation messages over the XBus output. So move x0 to x2 twice. Then we need to activate the motor, causing ACK and DAT to become the same, basically. Are we ever going to get a message telling us to go to the place we're currently at? I suppose it doesn't hurt to handle that case. It costs us like 1 power. Each time someone doesn't send us that, but it simplifies things to just, okay. So I think the thing to do is to test equal, oh, whoa. Alright. First of all, I sort of forgot how to control the motor. How do I control the motor? Pulsing it to 100 and then back to 50. We'll move it to the next. Pulsing 0 and back to 50 will move to the previous. Okay. So here I think we can use test compare in a kind of cool way. Right? So let's try that. So test compare ACK and DAT. Remember, DAT is where we want to go, and ACK is where we are. I think it'll be a little more clear if we write it this way. So we're going to be basically computing the difference between. Oh, let's label this as well. Move. So here's the cute little trick, I think. Is we're going to say oh, I forgot that 50 is do nothing? Yes. 50 is the do nothing state. So we're gonna have to be careful down here in done to like move 50 or something. No, it can't be in done, it has to be up here. Move 50 into P1, kind of like we did in the previous, I think it was the previous one, where we're working with that doll sound thing. Okay, anyway, so if DAT is less than ACK, we'll activate negative instructions, and so we will move, what's next and what's previous? Yeah, good, 0, okay. This is the right mnemonic thing, anyway. Move 0 to P1, otherwise move 100 to P1, and then sleep 1, and then move 50 to P1, and sleep 1. Ugh. I need like one more instruction again, I think. Because I need to jump back. Oh no, I need more than that, don't I? Yeah. Looks like we're gonna need another chip, at least the way I'm writing it. Because we need a couple of things. We need one, an instruction to tell this guy to wake up when we're done moving the motor. 2, we need a way to detect that we're done moving the motor. So how much of this crap, yeah, almost half of this is not related to moving the motor. So I think we're gonna have to separate that. So let's go ahead and grab another large chip. maybe we'll be able to do with a small, I don't know. But wire him up in the sort of obvious way. He's going to start with moving 50 to P1. And he's going to basically just handle all this move stuff. His life might be easier. Let's see. He doesn't exactly need to know what our current position is. He just needs to know how far to move, right? So, alright. Let's try implementing this guy for now. Because we were sort of in the middle of that, right? So, what we're going to do is sleep X on X1, and then, like, when we do get a message, we'll decide how far to move, basically. But instead of comparing dat and ac, what we're going to do is move x1 into ac, which is going to be the only register we'll use to this, and we'll use it to decide how much further we need to go. And so instead of comparing ac, we'll compare it to 0. Okay. If it's less than 0, we'll write a 0. If it's more than 0, we'll write 100. The trick is what to do if it's exactly 0. And the problem is test compare doesn't activate either plus or minus instructions in that case. So what I would like to do, ideally, is just sort of issue a jump at this point. If it was 0, then jump over all this stuff. But you can't exactly do that. We can add another test here and assume we were never told to move by exactly 0. Or we can move a test, we can put the test like up here or something. Yeah, let's just do it here. Test equal ac of 0, and if it was, then jump done, I guess. And we'll just put done here. We should always be what am I trying to say? It should be safe to just jump over all that stuff, because we should have as our invariant the fact that 50 is always on the line when we're done with it. And then here we'll just jump to move, to go back to this moving loop. And when we are finally done, we're going to have to let this guy know that it's time to activate the tools. So let's not cross the wires. Let's just wire them a little better, shall we? So instead of x1 here, we'll use x0. And in done, we will move 100 over x1. So we're not using all of this chip's I/O, and it seems like inefficiently written stuff. maybe someone smarter than me could figure out how to trim like 4 lines off of this and fit it on one of these guys. But 4 is a lot. Hello, why is it drawing? Get out of here, you dang wires. I don't know why it ended up drawing all those while while I was dragging this around, but whatever. So here's the idea. We're gonna write a thing, wait for an input, save the input, and test whether it was 0? Wait. We need to move this label. So we need to do that test every time. That's important. Now, we could put the test at the bottom, as I was saying. Yeah, that would save us 1 instruction, I think. And also some power. But let's not worry about optimizing this guy out. Let's just try to make him correct. Okay, so let's go look at this motor guy now. We're still using DAT and ACK. I think we have to, right? Yes, because we have to look at the first XBus inputs, and then if it wasn't 999, we have to do something with it. So we have to store it somewhere, and that can't be in the place where we store what our current position is. But it might be better to store our current position in DAT now, right? Yeah. I think. So like, if we put our current position in DAT, let's say it's 5, and the place we're being asked to move to is 7, we can put 7 into ACK, fine. And then in order to send the message, we can just subtract DAT from ACK. Great. And then we'll send that over to the motor. Right, that would be 2. 7 minus 5. But then we're going to need to put the 7 into DAT somehow, right? To indicate that we're done moving. And I guess we can always undo the subtraction by adding DAT back in and then moving from ACK to DAT. Seems a little bit weird, but okay, I think we can do that. Alright, so we're gonna move not into DAT, but into ACK. Can we avoid sending these 2 early somehow? I don't think so. Yeah, I don't see anything clever. Well, I forget. What happens if you try to move? Does time advance if you're trying to move and nothing is waiting to listen? I don't think it does. I think you have to... Because if that were true, we could cut down the amount of stuff that this guy is having to remember, I think. By saving... Could we? By saving the second input, like, on the XBus wire itself, maybe? Even if it weren't true, we have another couple of bytes here. We could maybe shrink this down, but let's write it the simple way, and then we can think about optimizing it. So what are we doing? We're writing both of the things to x2, telling it what to do. and then we need to compute what to do to the motor next. We couldn't have sent to the motor before sending to the tools because we needed, well, I guess we could have sent first, but whatever, it doesn't really matter. Let us next subtract dat, right? Sub dat. Move ac over x3, that's telling it how far to go. Add dat and move ac to dat, I believe. I think that's the thing to do. Is to just say, let's say we are at 5 and we got a message saying 7. Dat contains, at this point, 7, no, it contains 5. We have 7 in ac, so we sub dat, we get 2, we send that over. And then we add dat back in again, which was 5, we get 7, and we move ac to dat. Now we've stored 7, which is our position. Fine. So the interesting thing, I think, is that all of this has happened during the same initial time cycle. So if we wanted to, we could we could do these two things after doing all that addition. I'm not really sure what the point of that would be. Well, okay, pin is not connected. Which pin? X0, P1. Oh, yeah, let's get rid of that line, huh? We're at 10 instructions. If we could squeeze out just one more, we could use a smaller chip. That would be kind of cool. Alright, so to a first approximation, without doing any error checking, this kind of seems like it might be done. It's probably not, right? I mean, something is probably broken. But let's start testing and see what it is. I'm eager to finally push the buttons and see some inputs flow through. Okay, we moved to 9 so we discovered that it was minus 9. Hello? Oh, it just did dat instead of act. What a guy. Alright. Try again. Oh, here's an interesting fact. Here's how we can squeeze out one more. Is that now that we're no longer looping in here, we don't have any more conditionals to do. So instead, we can just prefix all these guys with, with minuses. And remove this label. And now we're within the size limit for a smaller chip. So that's kind of cool. Right, we received a 2. AC is 2. Is it minus 99? No. Therefore, write stuff to x2. So he's stored those away in his registers. Oh, this sleep x for x1 should be x0. So that's something to fix. Because we're now getting our go signal from the motor controller rather than from the main processing unit. But okay, we sent that guy the stuff. Now we subtract dat, and we get the fact that we should move by 2. So we send that over. There's a 2. Now what's this guy gonna do? He's moving into AC. Is it equal to 0? No. Now compare it to 0. And it says, okay, we need to move up, so here's 100. Now it's sleeping, so let's look at this guy again. He managed to store 2 in his dat, and he's sleeping. this guy. We move 50 back, and we sleep for 1. Everyone's sleeping. Now we jump back to move to see what to do next. Oh, and this guy, yeah, he's back to reading the input, even though he doesn't necessarily need to. If we wanted to save power, we could maybe have this guy send him a message saying, "Hey, time to wake up." But in the meantime, it's not too expensive to just have him wake up regardless. Okay, now we check whether Ak... Oh no, we missed, we missed the step where we're gonna change what Ak is. It's a little bit hard to do because we only have one space for one instruction, right? So, like, oh wait, do we have only one instruction? Maybe we have 2. No, we just have 1. So the obvious thing to do, I think, would be to add something like, in this case, we say add 1, right? And then in this case here, we would sub 1. Like we would get closer and closer to 0 in that way. Wait, why is this done saying move 100? It should be move 50, I presume. Wait, why was it? Oh no, it was to x1. Right. So if we could find a way to remove that, then we could save that one instruction we need. If we could simplify the testing that we're doing, because we're comparing to 0, and then we're also like comparing to 0 again, right? It kind of sucks. But I'm not sure how to do better. It would be really nice if we could somehow use gen. Ah! I think we can, right? Well... I was thinking this sleep 1 here, right? It would be nice if we could remove that. And I think we can, actually. Yeah. So what we'll do is, instead of moving 100 to P1 and then sleeping 1, we'll say gen P1 1 0, saying send a signal for a positive for 1. And then in this case, we'll say gen P1 0 1. Right? So we took these 2 instructions that were writing either 100 or 0, and we replaced each of them with something that says write 100 or 0 and then sleep for 1, basically, right? I think. And that way we were able to remove the single sleep instruction that they were both using. And that bought us the space to add in a sub. I think that should be okay. So let's see how we're doing now. Okay, we wrote some stuff. Now let's... The motor is the interesting thing, of course. So move is, first we see, is it 0? No. Now we see, is it 0 again? And we gen P1, we send it high, and we sleep for 1. Great, so now that's done. We sub 1, and AC is now down to 1. Meanwhile, we send it to 50, so that it can go back to its neutral state, and we sleep. Great. Now we jump back to move, and we do the same thing again. Sub 1, move 50, sleep 1, and this jumps back to move, where it will decide to go to done. Right, jump done. Done says move 100 to x1. So now we're writing to the tool controller, which says move x1 to p1. Oops, wrong input. Should be x0. Okay. Yeah. There comes the 100. We move it. It's the 100 we wanted, of course, and we sleep for AC, which is 2. And then we, in this other guy here, we say gen P0 dat, which is our second tool controller thing. Oops. I see. So move x0 to P1. We need to turn off P1 now. Move 0 to P1. This gen will take care of turning it off, but you know, it's actually more instruction. I don't know, whatever, it's fine. It's the same amount of power, and it's not actually, yeah, whatever. Alright, so where were we? We were looking at what happens when this turns off, right? Yes. Now this time we move 0 to P1, and we gen on P0 for length of time 2. Alright, now we're getting 5, telling us to move from 2 to 5. So hopefully we send a 2 and a 2 over to this guy, yes. We send hopefully a 3, yes. Alright, this all looks pretty good. Look at it go! It's just cleaning shit. Woo! Good work, robot. I bet it's probably doing something sinister and nasty, though. Whatever. Alright, so... not impressive by any means, in terms of score. But we did finish it. Oh, that's right. And we actually can improve a fair bit, because this guy can be shrunk. We... oh no, it needs... Damn it. Both of these guys need all their registers, even though they're short enough that they don't need all of their instructions. Ugh. I wonder if it would have been easier to use an external RAM somehow. Oh well. Yeah, I don't think there's any really great ways to optimize this. So I guess I was talking about being able to remove this guy's reliance on an extra register by sending the last value like over XBus. But I think there were a lot of reasons that wasn't going to work. One is, I mean, I could check, but I think if you try to write to XBus and there's nothing there to receive, it blocks and won't sleep. So that would be no good. So we would need the value to be in here for a length of time, right? Because we can only read it during this time interval, and we need to we need it to be blocking until this time interval if it's not going to sit in the register. So, and the other reason is that it would increase the number of lines of code spent in these two guys, meaning we would need the larger chips after all. So I think for the moment anyway, we're going to just be happy with this. Maybe we'll revisit this solution when we unlock some cool new part, who knows. But I think that's it for this one, and let's see what everyone has to say about our amazing farming robot. I received word that he was happy with the result of our work. Part of a much larger project, but nobody I speak to will say anything more. Yeah, very suspicious and sinister. Okay, well, that was that puzzle. It was fun. I hope you guys enjoyed it as well. Thanks for watching, and I'll see you next time.